Hello, everyone. My name is Chris Berg. I'm CEO of a company called Data Kitchen here in Boston, Massachusetts, and I'm going to talk about something. I'm going to talk about some people that you may know a little bit, your data nerd friends, and how there's a whole world sort of next to the kind of transactional systems we build, data analytics, data science, engineering, visualization, and how it's really troubling, and how the principles that you know about from Agile and DevOps and Lean are the way forward. And so broadly speaking, and I've been an engineer for a long time, and there's transactional systems, right, they tend to store transactions, right? So whether those are web logs or whether they're e-commerce transactions, and we've grown in love to build them by DevOps principles in Agile. Now, there's a bunch of systems that take data from those transactional systems. And in general, I'm calling those analytic systems. And they extract data, they load data, they visualize data, they run predictive models. And I honestly think that they're built with hope and heroism. They're really stuck in the dark ages. And so it's almost as if the whole DevOps movement didn't happen. And so I've been devoting my company's time for the last 8 years to sort of bring the idea of DevOps to analytic systems. And so I'm going to talk about 4 things. First, I'm going to talk about why this is a big problem and really kind of how empathy can be the way to go, and that the people that we're working with are suffering, and what you know can help. And so everyone's heard about big data or now AI. There's like so much buzz. And when I got into, I spent 15 years in the software industry. And then 15 years ago, when I got into data and analytics, I had to explain to people what that was. Oh, I do charts and graphs. And now, analytics is everywhere, football games, airports, and it's a huge market, right? There's lots of people. And in some way, there are more people who are creating insights from data, probably by a factor of 10 than creating software, if you consider all the people using Excel or visualization tools. And the reality is most of these projects fail. And 80% of models never get into production. The number of companies self-reporting being data-driven, which is kind of the highest point. Like if DevOps are trying to be digital, from an analyst perspective, companies being data-driven is the highest order bit, and it's falling down. And honestly, we just did a survey with another company, and we found that the 80% of the people want to have a therapist because they're so stressed out, kind of dealing with the production and insight generation process. And so one way to think of it is that like the data and analytic industry is producing pacers, crappy cars that don't last a while. And Pacers were terrible cars in the 70s, and they, American Motors went out of business because Toyota figured out a better way to build a system, and a better way to build cars. And so I think data analytics is a lot like it. We're producing Pacers and not Toyota Corollas. And in a lot of ways, if you read the DevOps literature, best of breed DevOps companies do a lot of things very well. They do CI and CD very well. They do monitoring well. They do infrastructure as code very well. They do value stream management very well. And a lot of cases that a lot of companies in data and analytics, they don't do things very well. They take months to deploy. They don't even know if they have errors, and they're constantly having their customers find problems. And they just go to a lot of meetings and carp and moan a lot. And so, I guess why should you care? Well, I've from a guy who spent 15 years in software and then 15 years in transactional systems and 15 years in analytic systems, it's almost as if, people are very much the same. And it's like they took a door. Their first job, they ended up doing data systems and analytic systems rather than transactional systems. And so they sort of walk and talk like you, but they have problems that I think your skills can help with. And they have roles like, data scientist, data engineer, data architect, a lot of data words, business analysts. And what they do, as I said, is they take data from a lot of places, transactional systems, and they create an analytic system from it. And so they also have a different set of roles than what we see in software systems. Instead of back-end engineer, front-end engineer, et cetera, they have someone called data engineers and someone who does data science and AI, data visualization, governance, and production operations. And there's just a lot of tools, and each one of these roles has got a dozen or so, or actually 50 or so different tools to choose from: open source, closed source, expensive, cheap. People have their favorites, and there's programming languages. There's the most popular language to do data and analytics works now is Python, in addition to R, in addition to Julia, in addition to other languages. And so just to give you an example of what people do. So let's say there's a data engineering team who gets some data from a transactional system. Let's say there's a sales system that keeps track of all your sales transactions. And Joe bought something and Kelly bought another. Now there's a person who is trying to take that data and understand patterns in customers. And so they do something called a segmentation model. So they take one group of customers and say they're high value and another group of low. And of course, there's only two people here, so it's not very hard. And there's a whole bunch of art to this, right? Sometimes those models are complicated. Sometimes they're simple if then else statements, but they generally are called data scientists, or sometimes they're called AI people. And then there are people who take that data and try to get it in front of people in a more visually interesting way. And so they use tools like Tableau and build things like dashboards. And those people sometimes actually mix in smaller amounts of data into it. And they use tools that are kind of technical tools. Sometimes they write SQL, sometimes they do drag and drop programming, sort of low code tools. And in this case, they added an owner to it. And then, like in IT, there's a governance person. And in the world data governance, what they're trying to do is say, what is this data mean? And what's its description, and where did it come from? And in the parlance is data catalogs and data lineage. And then there's people who run these systems. And so, unlike in development teams, these teams are largely disjointed, and they have their own development processes. Some people have no development processes. They do something, they get it working, they show it to a customer, and then it's done. It's in production. They push a button in their tool. Other people follow more waterfall processes. Other people just, they're just three people working and they're trying to get stuff done. And so, we've heard a lot about AI, and actually AI has its own unique development process. It's actually looking at data, what's called developing features on the data. So, and then trying to make predictions from those features. And that has its own iterative cycle, in addition to every other group here. And so, from customers' perspective, right, if we look at data analytics and engineering science, a bunch of stuff happens in the middle, right? Every diagram you'll see will have source systems, i.e. the transactional systems that you work on the left, and then value to the customers on the right. And maybe that value is a dashboard to a VP of marketing, or maybe it goes off to a website to do to actually help someone with a shopping cart abandonment model to help them help them get back and involved. But anyway, this stuff happens from the source data to the customer. And really what is happening now is that there's a lot of what I call hope and heroism. And so people are working night and day, nights and weekends, they're trying to get stuff done, and they hope that it works. On the other hand, there's a lot of sort of waterfall, slow, take months and distancing behavior where I get it up to this point. I don't know if it has any value. My job's done. And so and as a result, it takes forever to deliver new value. And also it takes forever. And this idea of iterative development that we talk about in DevOps, short increments of value delivery, focus on customer value, automated testing, automated deployment is actually pretty rare in companies. And so, and the other part too is that's funny is that when you do surveys, one of the number one problems that people have with analytic systems is they don't trust the data. And one of the biggest reason they don't trust the data is it's often wrong. And it's wrong because there's a problem in the source data, or there's a problem in the production of data. And this idea that you should observe data and check for quality while in production is actually pretty rare. You'd be amazed at how large companies just run open-ended processes where they manually do a lot of checking of the data transformation of the model and development. And then when it gets in production, they just hope that the data flows through is right, and then they rely on their customers to find the problem. And this is actually kind of state of the art right now, which is incredibly sad in my mind. And then another way to look at data and analytics systems is as a factory. And so source data comes from one side, it goes to the other. And those workstations on the factory are all those tools that people use. In some cases, it's a database. In some cases, on top of that database, they're running SQL. They have another tool called an ETL tool, which is kind of a visual way to transform data. Sometimes they're actually doing Python code on scripts on raw data to load it. Sometimes that data comes in batch, sometimes it's streaming, and sometimes they're running models on it in batch or in streaming. And then it ends up in a place where the data is put in a shape that's more amenable to visualization. And there's different techniques to do that. And a database schema often looks like a star, where there's facts in the middle and dimensions and entities out, whereas a transactional schema has a very different standpoint. And then finally, there's a governance. And so imagine this production process where data is going through in bigger, smaller, faster, slow. And these things, data's artifacts, data's being assembled and reshaped, and models and visualizations are being added to it. So it's a factory. And what's interesting about this factory is that in a lot of bigger organizations, there's not one team that works on this factory. There are different teams, and sometimes there are different teams in different locations. And oftentimes there's a IT team who builds a data warehouse or a data engineering team. And maybe in another part of the company, there's a data science team or two. And then maybe all over the company, there are people trying to make visualizations from that. And so the sort of Conway's law idea that we have in software actually applies here in spades. And it's just a lot more it's a lot more complicated problem. It's not just one front end team to a back end team. It's like you've got 2 back end teams, a couple of mid-tier teams, and then 27 front end teams, all with sort of a many relationship with each other. It's complicated. And so this is really this pattern of decentralized development, this almost social graph of how things are put together, is part and parcel of what the world of data and analytics today. As crazy as that may sound to you. And so, yeah, and I mentioned Conway's law, and what's funny is, Conway's law is kind of, we speak of it as a negative thing, and I think it is, right? You don't build a technical system according to the best practices or the best way the technical system itself wants to be built. It ends up following the way the organization's done. And I think that's a lot of case in data and analytics, and the organization structure actually is embedded in all the work. And that actually has a huge issue in a lot of organizations, because sometimes there's, just like in back-end and front-end software engineering, sometimes things are better done on the back end, and sometimes things are better done on the front end. And that decision it should be done from what's best for engineering, not just because one team has time and the other team doesn't. And so, the basic idea is, how do you fix these problems? And I think the first thing is that one way that you think about it is to apply the ideas that come from Agile. And the gold star that people should go towards is, how much am I making my customer successful? Not am I building something, but is my customer successful? Are they using my insight to actually change their life? And then the second thing is that they don't really think about the data. Think about the processes and steps that act upon the data. So think about the factory or the system, and not the particulars. Think about the how you do things and not what you do. And that's a different mindset. And it's very familiar to people in DevOps, right? Because you think about deployment all the time. You think about systems. So you have teams who are thinking about the processes acting upon software systems. And so there's really these 3 software cycles. And one of the biggest things, just in a simple way to think about this, is that in software, you're iterating quickly to develop a product that has an interface that you're trying to get the customer to use and like, right? And that's true. You're doing that in data and analytics. The product is charts and graphs, or the product is a table or something full of data. The other part that's different is you're iterating on the data itself, because you don't know if the data is actually predictive, or data tells a story, or the data answers a business question. So we've got another iteration cycle here. And to people who do data and analytics work, they've got these 2 cycles in their head. Is the data telling me something? And can I actually, what I'm creating from it, is it explanatory? And so from a team work cycle, we've got these different teams here represented by the different color circles, the bar charts and the idea and the gears. And they have their own development process that's largely separate. They have their own deployment process, and then they have their own production process. And so these process cycles are tough for people. So first of all, in production, as I said, a lot of people have a lot of errors. They're running their factory to produce AMC Pacers and not Toyota Corollas. And then second, the process of getting things into production is very hard for a lot of organizations. And just in the past few years, some organizations, you can imagine their deployment process is largely manual now. They're sort of walking things and patch scripts and Word documents. And some organizations are actually starting to implement some CI systems, which is good. It's sort of they're making the railway, but they're oftentimes are implementing the CI systems without any signaling. And I've seen companies do. They've improved now because they've got sort of automated deployment, but they don't actually get the full velocity. They're 10 weeks, even though they automate the movement, because it's not just about automating the movement, it's about how you actually regression test and how you actually coordinate the development teams. And so these process cycles are complicated in data and analytics because of the social structure, because of in data and analytics, you're really testing data much more so than you're actually testing the software. And how you do that across development, deployment and production is hard for teams. And so in a lot of ways, these process cycles of error rates in production, cycle time of deployment, collaboration in development, and sort of process measurement are very important in data and analytics, just like they're in some ways important in software. And so, I've talked a lot about these people, data scientists and data engineers who, you may have lunch with or you may know. And when you sort of pull out your phone and are able to go in and log on a website and deploy some new JavaScript and new Java code off to a website during lunch, and those people look at you like you're crazy and taking a big risk because it takes them months to put 10 lines of SQL in production. I just want to emphasize that sort of your data nerd friends are suffering. And they're suffering in a very similar way to the way that software teams suffered. And I know that because I managed teams many years ago that were working in an unagile way. And, I was part of this sort of hero culture of going in and working nights and weekends. I remember, working on production systems live. And then there's a lot of fear on the opposite of that. Is the culture of like, we just got something working, we're not going to change it. It's working and don't touch it, and the other part to that is just there's, interestingly enough, since a lot of people don't test data in production, they don't even know if there's errors. They're sort of willfully blind to whether the system's up or not. And in software, that used to be the case. You didn't know if you just wait for the emails from your customer, hey, the website's down. And you didn't have sort of checkers and pulse reports and checkers to see if it's right. And companies like Datadog and PagerDuty didn't exist. And we've come to believe that that's part of what makes good software, is that you can tell it, the software, you have software that'll tell you that your software is actually working correctly and alert you if you're not. And that's not the case in data and analytics. And these rates of deployment and high risk in deployment. And, there's a lot of review boards. And, I was just talking with a customer this week, and they had, it's a huge team, 100 team. They had a whole bunch of problems in production, made them all freeze up. And then the top 3 people on the team ended up having to review everything, have to go through a technology review board. And as much as you hate this, if you look at books like the Unicorn Project or the Phoenix Project, these are eerily parallel to it. And in fact, I got to know Gene Kim and sort of helped him write sort of about a chapter around data teams in the Unicorn Project, or he did the writing and I talked to him about it. And so I think this idea that data teams have problems is important. And what we've been calling it is data ops, and there's actually other words for it. Some people call it model ops or ML ops, or biz, and the ops term's overused, of course. But 5 years ago we wrote a manifesto, and it's had now like 15,000 people sign it. It's sort of a ripoff of the Agile manifesto, and it's gotten on the Gartner hype cycle, and there's a lot of search growth. And what we're finding is that people are more and more, and actually this Gartner hype cycle, if it's an indicator of everything, the idea of data ops has moved up quite a bit in the past few years. It's a bit a couple of years old, and so my hope is that these principles on being able to deliver quickly, focus on value to your customer, focus on automation of testing and deployment and environment creation, building, focusing on the how and not the what, having a team of people who do data ops, DevOps, model ops, I don't really care what node it's, who are working to make their data engineers and data scientists successful, just like DevOps engineers are working to make software engineers front and back successful. And I think that that's helpful, and I'm seeing more and more of it happen, but it's still early in a lot of organizations, and they're still learning. And so, we've had to define it, what data ops is. And so when I first started this journey now, when we first started talking about data ops like 5 or 6 years ago, I went to conferences and no one knew what we were talking about. I'm a middle-aged guy. My company's name is Data Kitchen, and we wore chef's hats and gives out wooden spoons. And people literally would laugh at us, like, "What are you? I don't get what you're talking about." And so we've had to talk about it. So we defined the term data ops, wrote a manifesto, wrote the Wikipedia article, and we've written 2 books now that talk about what data ops is. And and in some ways, the differences between data ops and DevOps are important, but they're not important. I think number one, they're not important because it's basically the same idea. Focus on value, iterate quickly, automate the shit out of things. It's important, this automation and testing and building systems next to your system that help your teams innovate. And whether you call it, DevOps or DevSecOps or DataSecOps, I'm not so big on the nomenclature, but the ideas are the same. However, there are differences between software, and there's different people, first of all, and data engineers, data scientists have a different perspective on the world than software engineers. And DevOps is more front end to back end, and data ops is more many to many. And there's a lot more sort of factory methods in production than there are in data and in software. And there's just this complexity because there's just a polyglot set of tools that people use. And so I think they're conceptually similar but different in practice. And likewise, just the process of CI and CD is similar, but there's more to it. And I've tried to coin this acronym that no one is picking up because it sounds awful, CSMOIDM. And one of the biggest differentiators is how do you regression test a full set of data and analytics from source all the way to value creation. And in that, you've really got to have a good environment. You've got to have test data that's representative of production. You got to pour that test data into your analytics system and run a whole bunch of checks against that data. And so that's why it's a little bit more complicated than just DevOps and CI and CD. Conceptually similar, but in practical, very different. And so what we've seen with our customers is that if you can get things into production with lower risk and quicker, you end up, just like in DevOps, you end up being much more successful. You are able to iterate quicker. Your team is able to learn more. And honestly, it's just more fun. And you don't have to sit in so many meetings, and you don't have to suffer with kind of going in the morning. And when I started in data and analytics, I had a team of people who did data engineering and data science and data viz who worked for me. And I hated going to work in the morning because I would get an email, something's wrong, what broke. I'd have to go around and triage it and then call the customer and beg forgiveness. And I hated that life, when I wanted to know that things were going to work before it got into production. And I wanted to know if someone gave us some bad data in our process before it got into production. And those things, and what I found is that took a lot of time and effort. And we founded a company to generalize those ideas that we figured out in 2006 and 2007 and produce software to do it. And what we've learned is if, like the pain that I had back in a dozen years ago, there's a lot of organizations who are still living with that pain, and I don't think it's tenable. And I'd like us to stop it, because our teams are suffering. And what I found is very similar to DevOps, is that you can kind of push up on this graphic equalizer. You can actually get things into production with low risk fast. You can actually run your full analytics system, invariant of whether your data providers give you crappy data or your servers go down, and have just incredibly low errors. And unless you've worked in data and analytics, you don't know how often teams are having fire drills because the data's wrong, or they've done something stupid. And you can have less meetings. You can actually build a system that allows you can collaborate on the system instead of collaborating through Word documents and team meetings and technology review boards. And one of the most ironic things in data and analytics is there's in software, we've talked about value stream management and measuring your value stream. There's just incredibly low process measurement in data and analytic teams. Like, they don't count their errors. They don't count how fast they deploy. They don't measure their own team's productivity. They don't know what their value streams are. And so it's ironic that you have teams who are devoted to giving data and analytics who are not very analytic about the work that they do. But I think if you apply these principles, you can push up on all these. You can have very low errors. You can get things into production with very low risk quickly. Your teams don't have to go to so many meetings, and they get more done. And you can actually have great reports that show how well your team's doing. And if you do all that, you actually get much happier customers, and you're actually much more productive. And you've stopped the sort of heroism and hope that is endemic in a lot of data and analytic teams. And so my plea here is that you guys in DevOps start going over on data and analytic teams. And so I guess what's my plea? My plea is that you start shaming people in data and analytics teams, because like what they're doing sucks. And the ideas that you have, that you've learned from building software, apply. Yeah, there's some things that are different. But I'd like you to join and switch and talk to these people and understand, because these principles that came from manufacturing, that came into software, need to go into the world of data and analytics. And here's one thing I'd like you to do is ask impertinent questions to your data. So you're at lunch, right? And you've got a lunch with a data engineer, a data scientist, and you're just talking about things. Just ask them some questions. Are you actually using source control? Is your model in Git? Is your data workflow in Git? How many automated quality tests do you have in production? Like, if someone gives you bad data, do you know if that happens, or does it go out to your customers to find it? Like, how do you regress your analytic systems? How long does it take you to deploy your models, your BI reports into production? Is it automated? What's the risk? Like, how up to date is your development environment? How often are your business users finding errors in the data? Just ask these questions, and you'd be surprised. You'd be shocked, because I think if you know DevOps, you're going to know the answers to this. Like, I think even if you don't know very much about data and analytics, you're going to know the answers to this, and you're going to have an idea of how to solve it. And so, not to say that there's some things that you can't learn, because data and analytic systems are different than transactional systems, but these things, this focus on these impertinent questions and getting people to answer, I think could be very helpful. And maybe it's shame, or maybe it's an opportunity I think of it more as it's an opportunity for improvement for our data and analytic teams. And so my company has written now 2 books, a manifesto, we have a software product. And actually, if you want to interested in a section from the Unicorn Project on DataOps, you can download it. And so, my plea to you as DevOps leaders is that, simply the data world's wide open for your ideas. It's big, it's suffering, and you can help. And so I'm hoping, as I talk to this conference, that people will get in the back of their mind, I'm kind of interested in this data thing. I've been, doing DevOps for a while. Maybe I can walk over and help those teams. And that would be just great, and from my mind. So thank you very much. That's all I have today. And I appreciate your time.